I think we left off here, and what I was trying to say is the energy for the heart to beat, which when you think about is kind of scary because it has to beat all the time, comes from breakdown of not only glucose, which we think about, but also lipids, fatty acids. And then also because the heart has, all of this needs to be done aerobically, so the heart actually has circulating hemoglobin plus the circulating hemoglobin that's in blood, but there's also myoglobin molecules that are unique to the muscle fibers of the cardiac area. So plenty of oxygen normally for the heart, plus plenty of energy normally for the heart. The way we define a heartbeat is a cardiac cycle. And generally, since it's a cycle, it's cyclical. So we can start it anywhere, but generally most of the time it's started with the atria, followed by the ventricles. And so the cardiac cycle is defined as the period between the start of one heartbeat and the end of another. During each cardiac cycle, each heart chambers goes through two basic phases, contraction and relaxation, or we call them systole and diastole. And the pressure relationships are what's responsible for the movement of the blood through the chambers. They're very, very dependent on the contraction. The pressure changes and contraction need to be synchronized. Now remember, water and blood is a liquid, basically flows from an area of high pressure to low pressure, and that principle is what's going on in the heart all the time, is you have blood flowing from an area of high pressure to low pressure. And so we have this image is in your book, and like I said, it's a cycle, so you can start it anywhere. But what happens is we usually start it with the atria, and the atria fill because the pressure in those atrial chambers is less than the venous pressure of the blood coming back from the body. Now that can shift and that can keep blood from going into the atria, but basically the blood goes from the superior and inferior vena cava into the atria because the pressure in the atria is lower than the venous pressure. What happens is these ventricles always have a little bit of blood in them. And what the blood will start filling into the atria. When the pressure in the atria exceeds the pressure in the ventricles, that'll push those valves open. Those AV valves will be pushed open and blood will rush into the ventricles. Now remember that the ventricles already have a little bit of blood in them. So actually the atria only put about 30% more blood into the ventricles. But what happens then is the blood in the ventricles, the pressure there exceeds the pressure of the atria, and that then shuts the valves again. So now we have the atria basically contracting. It's contracted and pushed all of its blood into the ventricles. The ventricle blood has pushed up against the valves and closed them. And so now they are very, very full. And so there is a term for when the ventricles are full, the contraction hasn't taken place yet. That's the isovolumetric pressure. So isovolumetric pressure. So you have blood pushing against the walls of the ventricles, but the ventricles haven't actually contracted yet. So we're kind of off our picture here. We're down to B. We have the atria contracting, and that's atrial systole ends and atrial diastole begins. So the atria have moved the blood down into the ventricles. The valves have closed, the AV valves have closed, and now the atria can actually start filling again because their pressure is lower than the venous pressure. And then what happens is ventricular systole begins with the closing of the valves. So now the AV valves are closed, but the semilunar valves are not open because the pressure of the ventricles is not enough to actually push those open yet. Semilunar valves, remember, are found in the area out to the aorta and also the area out to the lungs. But what will happen in the second phase of ventricular systole is the pressure rises and exceeds the pressure in the atria, in the aorta, and that then ejects the blood out of the ventricles. Now, what causes this pressure to exceed is the fact that these ventricles have contracted. So that's what we say about ventricular systole, the same as contraction. It's not really the same thing because it's not visualizing, it's not talking about the entire same picture, but contraction certainly causes systole, and that contraction basically is making the area that the blood is in even smaller. That increases the pressure of the blood in the ventricles, and that makes that pressure greater than the blood in the aorta, pushes it on out. That is late ventricular systole, or second phase of ventricular systole, if you think about it. And then what happens is the blood pushes out, not all of it, about 40% of it is all, and then when the blood in the ventricles pressure is less than in the aorta, that semilunar valve will close again, and that then will cause the ventricles to relax. Ventricular diastole, the ventricles relax, the pressure in the ventricles drops back, closing of the semilunar valves, and blood flows into the relaxed atria. So blood's been flowing into the relaxed atria, and then you go up into ventricular dystole late. All chambers are relaxed and filling. So the filling process goes on over and over again. Those are the phases of the cardiac cycle. The way you want to look at this is you want to look at basically when the valves are open and closed, and also where the blood would be based on the pressure. I think that helps me remember it. If I remember that blood is a liquid will go from an area of high pressure to low pressure. That helps me visualize why it moves from place to place. We have a few other pieces to add to this in terms of terms, but we will do this. The term that is included on this particular slide is this idea of end diastolic volume, and the idea of end diastolic volume is the amount that you have, is the amount you have of blood in the ventricle at the end of ventricular diastole. So end diastolic volume is the amount of blood that's in the ventricle total before it actually contracts and starts pushing blood out of the aorta. That rise in atrial pressure pushes blood into the ventricle, and then the atria contracts, so that's systole, so they do contract. That then will cause, remember, those valves are closed, all valves are closed, and end diastolic volume is how much blood is in that ventricle before it starts contracting. You actually have some image down here where you have this isovolumetric contraction. That again, you know, if there's a chamber that's full of liquid, that liquid is pushing against the inside of the chamber. This is isovolumetric. You also have isotonic contraction, that is when the ventricular walls are actually contracting and moving blood out. So end diastolic volume is a term that we're introducing here. The rest of it is pretty much it's the same as what we've talked about before, just talking a little bit about the open and closed valves there. Isovolumetric contraction, defined here as the ventricles are contracting but there's no blood flow. So that basically the push is against. The ventricular pressure increases because there is a contraction and forces the blood through the semilunar valves. I know I'm repeating myself, but again, in repetition, hopefully it makes a little more sense to you. Isovolumetric relaxation is when heart valves are closed, atrial pressure forces the AV valves open. So you have this least amount of fluid in the ventricles, but the most amount in the AV valves. They're pushed open, and then you have ventricular filling again. Auscultation is the therapeutic or the scientific or clinical listening to the heart via stethoscope. So listening to the heart definitely, but listening to the heart with science behind it, I guess you might say. And with this, we have 4 heart sounds, 2 of which we hear. The 4 heart sounds are S1, S2, S3, S4. S1 is the lub and S2 is the dub. The lub is caused by the AV valves closing. The dub is by the SA or the semilunar valves closing. The other 2 sounds are blood flowing into the ventricles and then a little bit from atrial contraction. Generally, the S3, S4 are not heard normally. These are terms just to know what the term means. So cardiac output is defined as the amount of blood pumped by each ventricle in 1 minute. And generally by each ventricle we mean the left ventricle. The right ventricle is smaller, pumps less blood, doesn't have to go as far. So generally when we're talking about ventricle or cardiac output, we're talking about the left ventricle. Although both can be measured, but we're talking about the left. And cardiac output equals heart rate times stroke volume. And so this would be something you would want to have in your head. Cardiac output equals heart rate times stroke volume. So the amount that's put out by that left ventricle times the amount put out by the left ventricle equals how many times the heart beats times how much is put out at each contraction of the ventricle. And so we measure that, and we measure that in milliliters per minute in cardiac output, because beats per minute, heart rate, milliliters per beat in stroke volume. This is a nice, if this graphic works for you with regard to understanding stroke volume, what you have is a simple pump. And if you've ever had to pump up a bicycle tire, I know I have several, when you bring the handle up, that reduces the pressure basically going into your bicycle pump. And then when you put the handle down, that increases the pressure. So end diastolic volume, in terms of the amount of air there in that pump, at the top you have the most amount of air possible when the handle is all the way to the top. That is similar to end diastolic volume, the amount that will be in those ventricles of that particular heart. And then what happens with ventricular systole, the pump starts going down, or the handle starts going down, and air starts then going into your bike tire, or you can think of it as blood flows out to the systemic circulation. And that amount of blood that goes out to the systemic circulation is considered stroke volume. And then you have this new term, end systolic volume, is what's left in the ventricle. And then you're going to go back up again, and you have ventricular dystole, which is filling again. We will pick this up on the next one.